Note that we are recording. All right. I'll put my camera on here. All right. Hello, everyone. Welcome to our last webinar on systems. Ben Matthews will be presenting this. Take it away, Ben.
All right. So this one's new this year. The infrastructure team has in previous years kind of, I don't want to say gotten frustrated, but we've wanted to help you all and answer some questions, and we've felt that it would be unfair to do so during the competition. So this year we figured we'd give you some kind of scattered hints. I'm not intending to teach you all how to be HPC engineers exactly, but more give you things to Google that may or may not be relevant to the competition. Most of them probably will be, so that's something to keep in mind. We'll also hit on security pretty hard because that's been an issue in past years. But to kick this off, let's talk about some logistics and reminders that you may need to know. So the big new thing this year is we would like to enforce some new rules regarding power per node. And the idea behind those was to encourage you to bring a real cluster, right? We've noticed in the last couple of years that the one or two big nodes with a lot of GPUs is getting kind of to be the architecture of choice. And it's a cluster competition, right? So we've structured the rules in such a way that we hope it forces you to bring a couple of nodes, and we're giving you some free power for a network device, which should hopefully further encourage that. The downside of this is that we need to track power per node to kind of ensure that you're following the new guidelines. As has been the case in the past, if you need to make any changes to how you've connected your machine to our PDU, you'll have to talk to a committee member after the initial kind of setup. You can use Y cables for dual power supply systems, or you can connect each machine into two PDU ports. Obviously, we're not going to provide Y cables, but we need to know by the time you run your benchmarks which nodes go to which PDU ports. And then, just as has been the case in the past, you absolutely may not touch any of the Ethernet or serial connections on the PDU. You'll be able to talk to the PDU directly, though, via your main network connection. There's some routing that makes that happen. If you do need anything to change anything in your PDU, again, just let us know. And Jeanette snuck in here a warning: if you're going to exceed the maximum allowed power, and there's a little bit of padding, but if you happen to cause any breakers to trip, that's a pretty serious event. You may be disqualified. Do that. And for those of you who aren't in the States and aren't used to our standard plugs, the plug looks like the picture on the slide. If you don't have a plug that looks like that, you probably have to get an adapter of some sort, which may or may not be easily available in the Denver area. So something to keep in mind. And feel free to stop me if there are any questions at any point, right? I have a lot here, but happy to answer questions. Likewise, networking, this hasn't changed much from previous years. You'll get a single 1 gig copper network connection. Little soapbox of mine, it's an 8P8C connector. It's not an RJ45, but commonly misnamed that. Oh yeah, and as Jeanette points out, feel free to put questions in the chat as well, and maybe Jeanette will yell at me if I don't see them. You'll get a small subset of publicly routable IPv4 addresses. Publicly routable is key, and we'll talk about that quite a bit in a minute. You must use that connection to get your cluster to outside things like the internet, the submission file server, and the PDU. External connections to your cluster from the internet aren't allowed, but you can connect out if you need to download software or whatever. That said, this network connection, and all of SciNet, but this network connection in particular, will be monitored for things that look like rule violations. And if we see something fishy, we'll talk to you. It's not like an automatic penalty. But with that in mind, VPNs or other traffic obfuscation methods might be interpreted as external assistance. Probably will be. So you're going to want to turn off that before connecting to your cluster or connecting your cluster to the competition network. But That issue aside, again, this is a heavily monitored network. I would encourage you to avoid sending plain text, chats, emails, things like that over that network, right? Probably best to do your Facebook or whatever on your phone. As far as networking gear, we don't really impose too many requirements on that. In past years, teams have brought consumer grade Wi-Fi routers that they've gone to Best Buy the day of to buy or something like that. However, again, having a Wi-Fi AP on your cluster network, maybe it doesn't mean you're getting external assistance and cheating, but it certainly looks bad. So at a bare minimum, turn off the Wi-Fi radio and make sure you change the default passwords on those things. Again, we'll get to this in a minute, but teams have absolutely been hacked in the past that way. Likewise, if you have a cell modem or something, we're trying to keep things fair for everyone, so we don't want easy ways for like your advisor to SSH into your cluster and fix things for you. All right. Submitting results. Each team will be provided with a dedicated file server this year. For those of you who've competed in the past, we've used cloud the last few years. We're not doing this year, so hopefully things should go a little smoother. But that said, we are doing a hardware refresh on our file servers this year, but it's not clear whether we'll be getting the new ones in time. So best to assume the file servers won't be super fast and we'll be utilizing spinning disks, a spinning disk. So, as a rule of thumb, small numbers of large files. Obviously, each judge will give you a a format to submit your results in. So you may or may not have any control over that. But in general, resumable file transfer methods are a good idea as well, right? Things like rsync and just overall submit early, right? Every year there's some team that's scrambling in the last 5 minutes to submit all their results, and usually they don't make it. So please don't be that team. And follow the yeah, and as Jeanette points out, that's a good point. You can always resubmit if you get better results, right? Get something, and then if you have better results in the last 5 minutes, by all means. Yeah, and then please try to follow the instructions with each application to the letter. We'll have a dashboard again this year that you can access publicly and will be displayed in the booth to show how things are progressing. Many of the applications, or at least some of the applications, will be auto-graded to, at a bare minimum, show whether you submitted them, but hopefully show something more interesting than that. And if you don't follow the submissions instructions exactly, then whatever script we come up with probably won't do the right thing. That said, if you mess this up, results are read by humans, right? The autograder results aren't final, so don't panic if the autograder isn't doing the right thing. Other reminders: for safety reasons, you absolutely must have a rack for your equipment. You won't be allowed to stack your equipment on the table, on a floor, unless you've talked to us. I know there's one team that might have a bit of a special circumstance with some slightly more exotic cooling equipment. So if you've talked to us, whatever we tell you is fine. But in general, you must have a rack. And again, invariably, there's a team every year that doesn't have a rack. Sometimes teams have been able to borrow steel from another exhibitor. Maybe your hardware vendor has a booth on the floor and you can borrow some equipment from them, but I wouldn't count on that. So please plan to have a rack. Yes, if you can bring your own rack, that's ideal. I mean, we don't impose anything on how you do the logistics. So, if you want to buy one when you arrive, if that makes shipping cheaper, fine. But yes, you should have a rack somehow. All right, so security, this was a bit of a thing last year. It's been a bit of a thing on and off. The network you plug your cluster into will be lightly firewalled by SINET, but the SINET firewall has been, let's say, imperfect in past years. So the goal behind the firewalling is to prevent the internet from interfering with the competition. It's not necessarily security. And the SINET firewall has gone down for periods of time in the past, and it's pretty well known. SINET is typically the largest research network on the planet for a week a year, and it gets probed very heavily. So, as a best practice in the industry, layered security, right? So yes, we will try to prevent the worst of the probing from attacking your cluster, but you should also do some security on your own to make sure that the internet is not disrupting your work. And SciNet in the past couple of years has alerted us to some SCC clusters scanning the internet, or trying to send malicious emails or otherwise causing trouble. Don't let that be you, right? Please represent us well. And anyway, if you get hacked, it won't help your score any, right? We may penalize you for that, and certainly it's not going to help the efficiency of your applications any. So you're responsible for the security of your software. We do provide some hardware security. Likewise, you're responsible for following any of the SciNet network use policy and any applicable law, right? In the SciNet policies here, and these slides will be available at some point in the next couple of days. Breaches of SciNet's policy may result in point deductions or being disconnected from the network completely, even if they're not necessarily exactly your fault, right? If they're caused by a security breach or some malicious software that you brought with you, or whatever the case may be, please don't attack the internet. However, the internet may attack you, probably will, right? That's just fact of life these days in HPC and any other IT domain. And likewise, the conference network is the internet, right? And our file servers this year should be considered the internet as well. They will be on your subnet, but you should treat them as untrusted. And I think it'll probably be obvious why in a minute. All right, so security checkup. We're going to do what we're calling a security checkup this year. I think Jeanette alluded to this in an email a couple days ago. The infrastructure team is going to be interviewing each of you about what measures you're taking to prevent security problems. And this is something that every HPC admin has to deal with. We'll be looking for egregious security flaws in your cluster from the perspective of the internet or the file servers. And, if we, are able to log into your cluster, that's a points deduction. But we will talk to you about it. And, if you are able to fix it, maybe that'll be a smaller points deduction. And this, of course, goes both ways. We're not infallible. Explore our infrastructure. If you find anything that we should fix, you think, let's talk about it, right? Let us know. But this only goes for SCC things, right? Don't scan the rest of SciNet. Don't scan the public internet. Don't upset anyone. To quote our fearless leader here, use your powers for good. And if you have any questions about where the line is on this, please ask. Post a discourse, pull one of us aside and ask. It's fine. All right, and Jeanette has a story about this, and she'll tell it better than I will. So yeah, go for it, Jeanette.
Yeah, I like to tell a story. I think it was 2017, but there was a team that, well, we had the firewall go down. The SciNet firewall went down, and all of the SCC equipment then was bare on the internet with no protection. And this happened late at night, like 10 or 11 o'clock at night. And there was a Polish team, and there was the student there that was doing their sysadmin stuff. He looked at his partner, who was typing madly away on his laptop, and he said, "What are you doing?" And he said, "Well, I'm working on this application for the SCC, right?" And he goes, "Well, you don't have a cable between your laptop and the router. How are you talking to the cluster?" And he checked it out, and he was talking to the cluster over Wi-Fi, which is not allowed, right? You have to use our connections, right? It has to be all there in the booth. So what was impressive was he turned around and closed the laptop lid on his partner's laptop and told him to stop working. He wired his partner in, got him back working, and then he contacted us. And he said, "I think the SciNet firewall is down." And so that was really impressive. Like he made sure he was following the rules, even though it was allowed to log in over Wi-Fi. I mean, it was technically possible. The rules didn't allow it. And so even though it was technically possible, he did not break the rules. He made sure his team was following the rules. That's just some integrity. And in our field, integrity is everything. And then the sad thing is there was another team their root password was 123456778. And so I'm expecting as soon as the SCC firewall went down, they got hacked. And they did. They got hacked, and then their machine sat there and scanned the internet. It actually brought down one of our switches for the competition. And so yeah, that was not good for that team. So I encourage you to use layered security. Don't rely on the SCC firewall as your only security. You should have many layers between your machine and the internet, just to make sure you don't get hacked. You don't want to be the person scanning the internet. And then follow the rules, even if you find things. And if you find things, tell us about them. That's all I got there, man.
Yeah, who knows? There might even be bonus points for telling us things. All right, so on that note, the rest of this deck is increasingly educational. So, what kind of security do you want, right? A couple really basic best practices. And as a general rule, any internet-facing device, and by internet-facing device, I mean pretty much anything you've assigned one of the SCC-provided IP addresses to, should only expose the services necessary to do its job. And in line with the SCC rules, that's pretty much nothing, right? You probably need to allow outgoing connections, but nobody should be SSHing into your cluster from the internet anyway, so probably don't really need to allow that. And again, if your device is reachable from the internet or the SCC network, at least have non-default strong passwords, right? And like Jeanette said, at least one past SCC team has been caught by that one. I think it's probably a couple every year, honestly. Certainly, SCC thinks there were a couple last year. I wasn't able to confirm that, but they let us know after the competition. And ideally, external facing services should be versions free of known vulnerabilities. And in HPC, we kind of weaken the traditional IT security model a little bit, right? And we don't worry so much about internal facing services. Services that don't touch the internet matter less, right? Because we trust our users to an extent. But certainly anything external facing, you need to keep patched reasonably well. All right, so the rest of this talk is me on an educational soapbox. It's going to go by really fast, and so kind of high level things to Google. But we want this competition to teach you things and to be fun, not so much to be really, really aggressive competition. And like I said, when I started out in HPC, this was explained to me as the egg model of HPC, right? You harden your exterior, and like an egg, you have kind of a softer, gooey center, right? You trust your users a little bit. And if you can avoid trusting your users, that's great, but often that's very difficult. And so as a regular user, it's pretty typical you could cause some trouble if you know what you're doing, but you probably won't because you like access to your HPC system. So not necessarily a good model, but it's way better than nothing, right? If you can keep us out of your cluster, we can't mess with your cluster. And by us, I mean us, Jeanette and I, or the internet. And the easiest way to do that is with a firewall, right? And when you're at a firewall, in general, you want to drop all the traffic by default, right? Disallow everything, and then allow the things you need explicitly. And just as a general tip that kind of trips everyone up the first time they write a firewall, don't assume you'll have DNS when the firewall starts. You want the firewall to start as early in the boot process as possible to protect the system as soon as possible. And I know most of you, probably all of you, are using Linux, and Linux has a very, very powerful stateful firewall, or Jeanette will say packet filter, built into the kernel, which means you can do things like accept packets that are related to an existing connection that the kernel was able to track. And that's pretty powerful, right? So a lot of times the model is to accept connections related to outgoing connections that you've already made and not allow anything in. And that's probably all you need to do. And there are a bunch of ways of interfacing with the kernel firewall, right? IP tables is kind of well understood by everyone and has been around forever. NFT is sort of the up and coming replacement for that. And then there are things like Firewall D that are more dynamic. They change the firewall based on things you configure. Personally, not a fan, right? HPC systems don't move around. That stuff is great for your laptop, but probably a little bit overkill. And we don't really like jitter in HPC. Also keep in mind, not everything is IP. Maybe you're doing RDMA over Ethernet, or you've got ICMP enabled, right? And so that's handled by different parts of the firewall in Linux. You can Google EB tables for a little bit of information about that. When we're talking about ICMP, you want to allow at least some parts of ICMP. The infrastructure team might try to ping your nodes and expect that to work as a troubleshooting metric. If you come to us and say, "Hey, our network is broken," that's a good thing. So if you just categorically drop ICMP, it makes troubleshooting more difficult. Path MTU discovery is another piece of ICMP you probably want to allow. And don't forget about IPv6. So this year's competition, we're not providing you with routable IPv6 addresses, but SciNet is pushing hard to get everything on IPv6. So most of the conference floor will have IPv6, and probably next year the competition will have that. So something to be aware of. And remember, you can filter outgoing traffic as well. I know in past years, teams have had trouble with laptops that want to VPN to their home institution and do whatever, right? And students may or may not even have access to turn that off. Well, if you have a router on your cluster, you can firewall that off and not allow them to do things you don't want them to do. So that can be a good technique as well. And this is not intended as a complete example, right? This is something I grabbed off a random car machine. But just to give you an idea what an IP tables firewall looks like, right? You see at the bottom of this, we have everything that's input is dropped, right? So we accept a bunch of things. We accept connections that we're expecting to get. We accept a few types of ICMP, and you can Wikipedia even, right? We'll tell you what these magic numbers means. And then we accept SSH connections, which again, any real HPC platform probably wants to do, but yours maybe not. And we log things we drop, which is optional and will generate a lot of log messages, but is very, very useful for debugging. And then we drop everything we're not expecting. And you can write the same basic thing in NFT. The ICMP filter is not exactly the same here. Again, I just grabbed this from a random NCAR system, but it's pretty much the same. Don't really care what you use, but again, you should use something because this has been a problem for teams in the past. And again, these slides will be posted. Likewise with SSH, if you were to expose SSH to the internet, and again, not suggesting you do, we're trying to teach generic HPC here, not necessarily how to game the competition, though there are obviously competition hints here. If you're going to expose SSH to the internet, use two-factor authentication, or at least use pre-shared keys, or at least use really, really strong passwords, right? And a lot of us like to track authentication failures and do a firewall level ban for IPs that have a lot of failures authenticating. Now, personally, I'm not a huge fan of this. That's a way you can interfere with legitimate users as well, but I turned off my camera. Whoops. That's something you can think about as well. So if you have a firewall, you need to test your firewall, right? The classic tool for this is Nmap. There are a few others out there. Masscan is one that's become a little more popular in recent years. Basically, the idea is you try to connect to things from a network that maybe should or maybe shouldn't be able to, and make sure that they behave the way you expect, right? And there are a ton of tools for this. HPing's another one. You can use Telnet and Netcat to make specific arbitrary connections and see how they behave. Write your own software to do this, right? However you want to do it, but like anything else, you don't know if it works until you've tested it. So, test it. And again, I gave you a couple example IP ranges out of the contest IP space here that I don't think will be used this year, but in general, only scan networks you control or otherwise have permission to scan. I'm giving you permission right now to scan our file servers, the Grafana instance, things controlled by the SCC, but absolutely not the rest of SciNet or the rest of the internet or whatever. You could, however, walk out to the show floor and try to scan your own cluster and see what happens, right? And you really shouldn't get anything because you shouldn't be able to remote access your cluster. But again, the SciNet firewall is not infallible, and yeah, if you find anything that you shouldn't, then let us know and we'll let them know. Another way to test things is by packet inspection, right? You can ask your switch to give you some data or record some data from a network interface, and depending on the particular network interface you're using, you might need some more flags than this, or to call ETH tool, or things, right? Again, just trying to get you some high-level ideas here. But I would encourage you to try this, and then once you collect some data, it'll probably be in the standard PCAP format, and you can look at it in something like Wireshark manually, or you could look at it with some automated tools that try to process PCAP files for interesting things, let's say, like Zeek or Snort. They're typically rule set based. And this will also teach you a lot about how networks work. So again, I'd encourage you to grab some network or grab some data from your home network and see what you see. Right? You'll learn a lot that way. Things to look for, right? Communications that don't make sense. Should your HPC system be generating bitcoins? Probably not, but that's a common sort of hack that happens to careless HPC systems. You can also find link layer problems, right? Excessive retransmissions, packet fragmentation, things like that. However, sometimes your NIC will try to batch up packets for you, and thus that will make the capture look funny. There is almost always a way to turn this feature off for packet captures on your NIC, but it's probably not the default because of performance. So, this can be misleading. It's something to be aware of. Communications that should be encrypted but aren't, right? And again, we're monitoring your networks. So if you're passing around on plain text emails or plain text SMS, or I don't know what people do with the internet anymore. Signet will see them. I will probably see them. Other people may see them. So, that's good best practice anyway, right? Encrypt your stuff if you can. Excessive traffic, right? Why is my HPC system talking to some server on the other side of the planet when I'm not supposed to be getting any sort of external assistance? Well, maybe you've got some malicious software or whatever. Or on large scale systems like Jeanette and I run, ARP floods are a big deal, right? Every machine saying, "Hey, I'm here," all at the same time, and that can cause an outsized impact on performance. But really, this is more of an art than a science, and I don't have a whole lot of time to teach you the fine art of packet capturing. But yeah, do some research on your own. Might learn something. Likewise, logging, right? It's important to make sure you're logging enough to detect incidents, troubleshoot hardware problems, whatever it may be, but not so much that it causes a significant performance problem for your system. Likewise, I'll just throw this out here. If you catch the committee trying to attack your cluster, or something that looks funny, now I don't want to hear about every SSH probe that comes from the internet, right? That's not very exciting, but I think you'll be able to notice if we're messing with you, and if that happens, let us know, right? It's good to, might be some points attached to that. You can use tools like rsyslog or one of the newer kind of cloud native things, FluentD. The Grafana people have something, Loki, I think it's called, to aggregate, filter, sort your logs, or some of us prefer good old fashioned grep. Actually works great. Backups, likewise, HPC sites should always have a disaster recovery plan. Now, you guys have a cluster that needs to live a week, so maybe less of a deal, but keep in mind disks do fail in shipping, so something to think about, right? We're trying to get ahead of anything that can prevent you from having a successful run at the competition. And again, less of a concern for an SCC team, but for completeness, we'll throw it in here, right? In general, each user or service should have their own account. Strong passwords are good. And the idea here is separation of concerns, really, right? You want to know that each service on your cluster, each user on your cluster can do what they need to do and no more. They can't interfere with each other. And we use the same principle when designing the competition network. You'll each be on your own VLAN. You won't be able to talk to each other's clusters directly. At least we hope. Again, layered security. Don't trust us, but that's the theory. And I don't mean to make this a security talk per se, but we've talked a lot about security, and keep in mind it's a spectrum, right? A totally secure system is one you've blown into 1,000 pieces and buried in the middle of the planet. But it's not a useful machine, right? if you can't access your system, it's not doing any useful work typically. So, make sure things can run. And, if you're working with PCAP files and monitoring the network, things like that, please keep your users' privacy in mind. Ideally, everything would be encrypted these days, but people make mistakes and transmit all sorts of things over the internet or the network. All right, something a little different, file transfer tools. Every year, there's at least one team that is struggling to submit their results, right? They haven't played much with file transfer tools, and it's either going really slow and they're trying to blame us, or they can't figure it out at all. So again, we're going to provide at least SSH access or SFTP access to your cluster. I think we're planning to provide rsync access to your cluster over SSH, meaning not that we're running an rsync daemon, but that the file servers will have rsync installed. And you have enough shell access to do that. So, I don't care what tool you use, but pick one of these, play with it, know how to use it in advance. And again, I want to stress, submit early. Submit something early so you know you can, and submit early anyway because the file servers may or may not be that fast. You do each have a dedicated file server to keep things fair. You have a dedicated network path. There should be no oversubscription or congestion anywhere in the path, but they're not super fast. So please keep that in mind. So, yep, SCP, very easy. The -R lets you copy directories. Syntax is there. rsync, some people find a little more confusing, especially with the trailing slashes, right? The trailing slashes mean to either put things in a directory or get things from a directory and copy those. If you don't have the trailing slashes, then it will copy the directory. And there are a bunch of flags for rsync that may improve its performance. This is just to get. Personally, I also like to throw in -- progress because I like to have something to look at, but that's up to you. And there are some newer tools like rclone that have an SFTP backend that might be able to add some parallelism, maybe make things a little faster, maybe not. So yeah, again, do some research, figure out how you want to do this, but please figure out how you want to do this, and don't be stressed about file transfers at the last second. And the way this works is we'll give you a little piece of paper or email. I don't know what Will's planning to do, but some information with where your file server is, an account to log into on it, and some basic network information. Here's your subnet, here's a DNS server you can talk to, here's an NTP server you can talk to, things of that nature. Likewise, data analysis while you're troubleshooting. These are things every Unix user should know, and most of them don't. For those of you outside North America, when Americans, we have an idiom, when we're looking for things, we're looking for needles and haystacks, a small thing and a big thing. Needle's the small thing, haystacks the big thing. So don't necessarily need to go through all these examples unless people have questions, but I just wanted to get you started. These are tools to know, and they're Unix itself, and the command line is an incredibly powerful data analysis tool. I can often beat fancy Hadoop clusters with a couple instances of grep. So, learn it, and it'll serve you well, both in the competition and in general. Not much more to say about that. A couple other commands to know. I polled the infrastructure team. I polled a few other people. Xargs, right? Take a list, feed it to a command. Clush is something we use at NCAR heavily. Run a command on multiple nodes or all your nodes at once and try to group, give you a list of nodes with each output. So maybe you have some succeed and some fail. You'll get 2 outputs and not 2,000 outputs. Very helpful. DF will ask me to ask you to not overfill our file servers. We do usually like that if you submit multiple times to give us multiple submissions on the file server, but if you're running out of space, we can be flexible on that, right? And I don't think you will, but be mindful. In parallel, Xargs bit HPC, right? Same idea, but a little more powerful and does things with parallelism, which you all might be interested in. I don't know. Hope so. And one last one that's been a big deal in NCAR lately, NUMA. Keep in mind, not every CPU has the same access to every device or every part of your memory or, whatever that any other CPU had. So this is a performance tuning thing, right? Understand your system's layout and pin processes based on that, and you'll generally get some better performance. And again, I'm not going to go into this in depth. Here's a couple things you might want to Google. Probably you've all seen this before, I hope, but we figured we'd throw it in anyway. And the last one, probably the most important one, reporting problems. So every year, especially during setup, you all come to us and say, the network's broken, my PDU's broken, something's broken. And honestly, half the time it's true. But we're going to be overwhelmed during that time, almost certainly. So I would ask that you try to report problems well, right? And what do I mean by this? Well, instead of saying it's broken, what is it doing? All right, what thing are you having a problem with? What is the problem, right? Okay, PDU port 1 isn't providing power. Much more, and I'm team number 3, right? That's much more useful to me than my PDU is broken. And we'll get you a resolution much faster. And this goes for network problems or power problems or whatever may come up, right? Your crate's missing, I don't care. Tell me who you are, what your problem is, and be as detailed as possible. Have you tried something to resolve it already? Is it repeatable? And you may have to convince us that a problem is a problem, right? We're going to get a lot of reports, things we've probably already tested, and we may not believe you immediately off the bat, so you may have to convince us. And of course, this is pretty typical of asking for support from your upstream network team or your upstream infrastructure team or whoever it may be, right? And we want to foster that experience that we all deal with daily, right? I spend half my time yelling at our hardware vendor in one way or another, right? So, please be nice. Don't yell at us. You'll get a better response that way. But yeah, provide us with all the information. And we'll be around the booth a lot of the time, or you can use Discord, or there will be a Slack channel, I think. I don't believe you're all on that yet, but as the competition gets closer, there's going to be a student Slack that you'll probably all get invited to. We monitor that as well. So again, I left lots of time, kind of a fast presentation, but I wanted to give you a bunch of time to ask me questions, ask Jeanette questions. Will's actually heading up the infrastructure team this year. He's on here too. And other than that, we've talked about some security techniques and maybe not pen testing techniques exactly, but things that could get you into trouble conceivably, right? So, use your powers for good, right? We want this competition to be as fair as possible. So Jeanette mentioned integrity earlier. Think about the spirit behind the rules. And if you have questions, talk to us. All right. Ask away. We're at your disposal for 20 minutes or so.
All right. Thanks, Ben. Is there any questions? Do people have questions? Give people a minute here to maybe find the mute button and formulate any questions. I know that was a lot. Ben is a fire hose of information, so.
It is a lot, but it's recorded and it's going to be posted. So, if you have questions later, Jeanette, I think our email addresses are probably published somewhere, I hope, maybe.
Yeah, and there's always the discourse. You can always ask on discourse, and we monitor that, right? So you can ask there.
Yeah, that's even better. Do that.
Or if there's anything people want to go over again. Anything you want Ben to go into detail about?
Totally ready. You're all professional sysadmins that have been at this for 20 years and know exactly what you're doing.
Ben and I might have been doing this a little bit longer than most of the students, that's for sure. Well, that's good, Ben. Nobody seems to have any questions.
Or we just overwhelmed them with things and they're stunned.
Is there anything you want to go over? Yeah, is there anything else you want to go back over or anything?
Not really. I don't know. Like I said, there are some hints in here, so think about that if you want. And I'm not going to tell you where the hints are, but good to think about.
All right. Well, I think that's it for today. So thanks everybody for coming. Thank you, Ben, for doing this webinar. We'll get these posted here in the next day or two. And I will stop recording.